Alright, hi class. For this lesson, we are going to do a stoichiometric calculation. So given in the equations over here, we have carbon react with hydrogen gas to produce methane gas. And please take note that for this topic, it is very important that we have a balanced equation. Once the equation is balanced, then we can see the stoichiometric relationship. So given of the 3 points over here, so 1 mole of carbon reacts with 2 mole of hydrogen gas. So according to the equations here. Or we can also say that 1 mole of carbon produces 1 mole of methane gas. Also, 2 mole of hydrogen gas produces 1 mole of methane gas. So the ratio between carbon, hydrogen, and also methane, we have a ratio of 1 to 2 to 1. So this shows the stoichiometric relationship for one equation. So the following are the questions given. This is an extra question which is not given in the notes. So you may need to write down and follow the following steps. For question number 1, if 75 grams of carbon is reacted, what is the mass of hydrogen gas needed in these reactions? So we copy down the balance equations given earlier. Okay, so 75 grams of carbon. So from here, we can find the number of mole of carbon. So using the mass given, divide by the atomic mass. So the number of mole of carbon, 6.25 mole. So from the balance equations, we know that 1 mole of carbon, it required 2 mole of hydrogen gas. So this is the stoichiometric relationship that we can obtain from a balance equation. So from our calculation, 6.25 mole of carbon, how many mole of hydrogen gas is required? So from here, we can do a simple cross multiplication. So 2 times with 6.25 divided by 1. Okay, so 2 times 6.25 mole of hydrogen gas. Therefore, the number of mole of hydrogen gas equals to 12.5 mole. So in order to get the mass of our hydrogen gas according to the questions, using the moles that we obtain, 12.5 mole, times with the molar mass of our hydrogen gas. So if you can see, the molecular formula is H2. So the molar mass of our hydrogen gas, 2 times 1 gram per mole. Therefore, the mass of hydrogen gas obtained over here equals to 25 gram. For the second questions, at room temperature, 1350 milliliter of hydrogen gas is used to produce methane gas. Calculate the mass of the methane gas. So remember that at room temperature, volume of 1 mole of gas will occupy 24.0 liter of space. Okay, and room temperatures refer to when pressure is at 1 atm, the temperature is at 25 degrees Celsius. Okay, so an extra information for you also, if the questions mentioned at STP, the standard temperature and pressure, it means that the volume of 1 mole of the gas occupied 22.4 liter. Okay, and standard temperature is 0 degrees Celsius, standard pressure is 1 atm. So in these questions, we are using room temperature here. Right, so to continue for our calculation, using the same balance equation, so given in the questions, we have 1350 milliliter. So first of all, find the number of mole of our hydrogen gas. So don't forget, just now we say that the molar volume occupied over here is 24.0 liter. And the information given over here is in milliliter. So bear in mind to check carefully the units, are they the same? So to find the answer for number of mole of hydrogen, we need to convert the unit into liter first, which is equals to 1.35 liter over the molar volume, which is 24. So the number of mole for our hydrogen gas equals to 0.05625 mole. Please kindly check your answer by pressing your calculator. So from our balance equations, 2 mole of hydrogen gas will produce 1 mole of methane. Therefore, if we have 0.05625 mole of hydrogen gas, okay, using cross multiplications method, so 1 over 2 times with 0.05625 mole of methane. And the number of mole of methane gas obtained over here equals to 0.028 mole. So once we find out the number of mole of methane gas, then we can find the mass of methane gas. 0.028 times with the molar mass of methane, 12 plus 4 times 1. Okay, and you will get your answer 0.448 gram. So for both of these examples, you're only given one information of either one of the reactant. So question number 1, they give you the information of carbon only. For question number 2, is given the information for hydrogen gas only. What if we have information for both of the reactant? Then it comes to our next topic, which is limiting reactant. If information of both reactant is provided, then we need to figure out limiting reactant and the excess reactant. So normally you will have more than one reactant, then you need to figure out which one is limiting and which one is the excess. So the definitions of limiting reactants refer to the reactant that is completely consumed in a reaction and it will limit the amount of product formed. In other words, the number of product formed depends on the limiting reactant. Excess reactant refers to the reactant that is not completely consumed in a reaction and it will remain at the end of the reaction. In other words, this excess reactant will have some left over after the reaction. Alright, so for question number 1, what is the limiting reactant for reactions of 0.5 mole of zinc with 0.75 mole of hydrochloric acid? So 0.5 mole of zinc, 0.75 mole of HCl. So this example shows that both of our reactants, the informations are provided. In this case, you need to find the limiting reactant even the questions doesn't request. Okay, because you have more than one choices. So there's two methods we can find out which reactant is the limiting reactant. So first method is to compare between the reactant and product. It is very important to make sure that the equation is balanced. Otherwise, you won't be able to find the exact answer. Alright, so to compare between the reactants and products, you must do two sets. To compare between zinc with zinc chloride and also between HCl with zinc chloride. Remember over here, if you are choosing to use the first method, you must use different reactant, okay, compare with the same product. Okay, remember, product must be the same and the reactant is different. So let's look at these working steps. So according to the balance equation, so when 1 mole of zinc is reacted, it will produce 1 mole of the zinc chloride. Therefore, given in the questions we have 0.5 mole of zinc and similarly because the mole ratio are the same, so we also have 0.5 mole of our zinc chloride. To compare between hydrochloric acid with the same product, zinc chloride. So according to the equation, when we have 2 mole of HCl reacted, you will going to produce 1 mole of the zinc chloride. Therefore, for 0.75 mole of the hydrochloric acid provided in the questions, we are going to produce, again over here, do your cross multiplication. So 1/2 times of 0.75 mole of zinc chloride. Therefore, number of mole of our zinc chloride produced over here equals to 0.375 mole. So let's compare the amount of product produced from both comparison. So when we're comparing the zinc reactant, we obtain 0.5 mole of zinc chloride. When we're comparing for HCl, we obtain only 0.375 mole of zinc chloride. So both of these products are the same. Then we will choose the one with fewer mole of the products formed because the definitions of limiting reactant says that it will limit the amount of product formed. Therefore, in this case, the limiting reactant is the HCl. So if you do a comparison, when you write down here is a fewer mole comparing between two of these values. Therefore, the reactant HCl is our limiting reactant. And please also jot down the reason why. Because it produces fewer moles of zinc chloride. Alright, so next is the second method, to compare between reactant and reactant. That means we are comparing between zinc with hydrochloric acid. So from the balance equation, 1 mole of zinc needed to react with 2 mole of hydrochloric acid. So if you put zinc on the left hand side, then it means that we will start with the zinc. So using the mole provided in the questions, 0.5 mole of the zinc will react with how many moles of our HCl. So here we need to do a cross multiplications. So 2 times 0.5 mole of HCl. Okay, therefore the number of mole of hydrochloric acid needed for this reaction, if we finish or completely using the zinc, we require 1 mole of hydrochloric acid. So this one, okay, the calculated mole of HCl using stoichiometry is the one that needed. However, in the questions just now, we have only 0.75 mole. So the 0.75 moles of hydrochloric acid is the one that provided in the reactions. Since the number of mole of hydrochloric acid needed is more than the number of mole provided, that means the mole that we have got is not enough to support the reaction. Therefore, we can say that the limiting reactant is HCl. So if you're choosing to use the second method, comparing between the reactant and reactant, we only need to compare 1 times. Okay, so either you're comparing zinc with HCl, or we can do another way around. When 2 mole of HCl is reacted, it requires 1 mole of zinc. Okay, so since we put HCl on our left hand side first, therefore we are using the value of 0.75. So this is another method if we want to start with hydrochloric acid first. So using 0.75 mole of HCl, find what is the number of mole of our zinc. So in this part, we need to do cross multiplication. So 1 over 2 times with 0.75 mole of zinc. Okay, therefore in this case, we have 0.375 mole of zinc, which is required. So for the values over here, 0.375 mole of zinc is the one that we need to use in the reaction. So if we finish or we completely reacting the HCl, we will require 0.375 mole of zinc. However, the number of mole of zinc that provided in the questions, if you look at the questions on above, the number of mole of zinc provided is 0.5 mole. So when you're comparing between the mole needed and the mole provided, so obviously the number of mole of zinc needed, okay, is less than the number of zinc provided, which in other words means that the number of mole of zinc needed is enough for the reactions to happen. Okay, the one that needed is 0.375. The one that provided is more than needed. Okay, it's 0.5 mole. Therefore, we can say that zinc is the excess reactant. Okay, because it is enough for the reactions, and after the reaction we still got some left over. So when you have already know that zinc is in excess, therefore HCl is the limiting reactant. Okay, so either one of this, so when we are comparing between reactant and reactant, you only choose one set. Either you want to start with zinc or you want to start with HCl.